Alright, our last example is one of those critical angle types, and it requires a little bit of thinking before you just jump into the problem. This one says, lucite is a strong, clear plastic used for many windows. Determine the critical angle for a water lucite system if the refractive index of water is 1.33 and 1.51 for lucite. Remember, when you're calculating critical angles, and this is always the case, for a critical angle, you have to be coming in at some angle, and then you're going to run along the x-axis after. It's going to be 90 degrees or more. Now, the way that you have to set this up is because you bend away from the normal, that means your larger index has to be on the top. Lucite has to be the incident. Water has to be the reflected. It will not work the other way around because you would bend towards the normal in this case. This is a case where it's going to speed up, and speeding up is going to bend away from the normal. So when you set this up, lucite is 1.51, water 1.33, and we'll set up our angle. We need to find that critical angle. So it's sine theta 1 over sine theta 2 equal to N2 over N1. What we want to do is find theta 1. We know theta 2 is 90, so it's going to be sine theta 1 over sine 90 equals N2, which will be 1.33 over N1, 1.51. And to find sine theta 1, or to find theta 1, multiply by sine of 90, so 1.33 times the sine of 90 degrees divided by 1.51. And then again, like we did in example 2, once you get that ratio, divided by 1.51, you'll get a decimal answer to find the angle second function sine of the ratio, and you should get an angle of 61.7 to 3 significant digits, 61.7 degrees. That's the critical angle that'll cause this to bend right along that horizontal line in this case. Always remember that if you're chasing critical angle, you're going from the larger index to the smaller index because you need to bend away from the normal.